This is a small project with NodeMCU Lolin version 3 and DS18B20, which is a one-wire digital thermometer. NodeMCU is short form for Node Microcontroller Unit. It is an open source software and hardware development environment. It is built around an inexpensive system on a chip or SoC called the ESP8266. It is an excellent choice for Internet of Things or IoT projects of all kinds. The NodeMCU is available in various package styles. All its designs are based on ESP8266 as core. The NodeMCU used for this small project is Lolin package style. The DS18B20 digital thermometer provides 9-bit to 12-bit Celsius temperature measurement. Each DS18B20 has a unique 64-bit serial code which allows multiple DS18B20s to function on the same one-wire bus, which makes it simple to use one microprocessor to control many DS18B20s distributed over a large area. The items shown in this video are some images, sketch code, serial monitor output when one sensor is used, serial monitor output when 6 sensors are used, data snapshot and logs stored onto a server. This image shows kind of top view of the connections of the NodeMCU with the digital thermometer DS18B20. As you can see, there are 3 jumper cables, black one, red one and yellow one. The black one is for the ground, the red one is for power supply and the yellow is for the data. As you can see, one end of the black jumper cable is connected to the ground pin of the NodeMCU, and the other end of the same black jumper cable is connected to the first pin of the digital thermometer, which is the ground pin of the thermometer. The red jumper cable, one end is connected to the 3.3 volt output pin of the NodeMCU, and the other end of the same red jumper cable is connected to the VCC of the digital thermometer, which is the 3rd pin. The yellow jumper cable, one end of it is connected to the D2 pin and the other end is connected to the data pin of the thermometer, which is the 2nd pin. You can also see a 4.7 kilo ohms resistor between data and VCC pins. It is for the purpose as pull-up resistor. Now this is the sketch code, which is made to scroll slowly. I suppose it is self-explanatory. There are plenty of serial printer lines to show as much information in the serial monitor of how the code is working or what it is doing. This is the console output of uploading the sketch to the NodeMCU. After the upload button is pressed, within a short while the code gets compiled. The compiled and compressed code will be uploaded as shown below. As you can see the progress in orange from the console output. This is the top view of the connections between the NodeMCU and the DS18B20 digital thermometer. Note that only one DS18B20 is connected. This is the serial monitor output when one sensor is connected. You can see the main function call number underlined with green and the sensor information with an orange arrow. The numbers underlined with yellow are the delay, actually the smart delay as I put it as. And you can see the gap between the two calls here, which is 60,004 milliseconds, which is underlined with red. The smart delay function is coded to keep the gap between the calls as near possible to 60 seconds, which seemingly is properly maintained. That is the fifth call to the main function, and this is the sixth call to the main function. You can see underlined in green. And the gap between the two calls to the main function in this instance is 60,005 milliseconds, and the temperature is 25.63 degrees centigrade. So that's the output when one sensor is connected. This is the top view of the connections between the NodeMCU and 6 DS18B20 digital thermometers. The ground pins of the 6 thermometers, that is the first pins of the 6 thermometers, are connected to the black jumper cable. The VCC pins of the 6 thermometers, those are the third pins of each of the thermometer, are connected to the red jumper cable. Note that the center pins of each of the thermometers, which are the data pins, are connected only to one jumper cable rather than 6 jumper cables. And that jumper cable is connected to only one data pin of the NodeMCU. This is possible because each DS18B20 thermometer has a unique 64-bit serial code, and the NodeMCU can request the temperature of each of the thermometer using the 64-bit unique serial code. This is the serial monitor output when 6 sensors are connected. You can see that the setup function is called first, and it gets the unique 64-bit serial code of each of the 6 sensors numbered 0 to 5. And you can see the main function call number underlined in green, and you can see the orange arrow marks pointing to the information of each sensor, their addresses and the temperatures. The smart delay function, the delay numerics are underlined in yellow, as you can see. The delay numbers are 54, 1, 0.4, 0.1, 0.04, and as many 0.01 seconds as required. You can see the gap or the duration from previous iteration to this iteration underlined in red. For example, in this screen it is 59,995 milliseconds. The smart delay function keeps the duration between each iteration to as near possible as 60 seconds. For example, here you can see the number with red underline 60,004 milliseconds, and also you can see it is the 6th call to the main function underlined in 6. This is the 7th call to the main function, as you can see 7 underlined with green. And that's the 8th call. The loop might be iterating as many times to reach the 1 minute duration, but the main function is only called when it reaches the 1 minute duration from the previous main function call. And that's the 10th call to the main function, and the duration from previous iteration is 59,999 milliseconds. You can see the temperatures of each of the sensor: 25.25 degrees centigrade, 25.38 degrees centigrade, 25.63 degrees centigrade, 25.94 degrees centigrade, etc. You can see that all of those are not exactly same, so to make it accurate, some calibration would be needed for each of those thermometers. And that's the 12th call to the main function, and this is the 13th call. So that's the output to the serial monitor when the 6 sensors are connected. This is just another image of when 6 sensors are connected to the NodeMCU. This is the PHP code, which is just about 73 lines of code, including the comments. I'm supposing it is self-explanatory. This is the snapshot of the temperatures of the 6 sensors saved on the server, so it is shown in the web page. These are the temperature logs of the 6 sensors collected once every minute and saved on the server into a text file. These can be saved into a database table as well if needed, and graphs can be created if needed. That's the end of this video. Thanks for watching.